Humans, those intelligent creatures that are always looking for ways to make their lives easier, have been able to successfully harness a fundamental force of nature as perplexing as it is powerful, which is magnetism. The ancient Greeks and Romans knew as well as we do that iodistone can attract other pieces of iron, while the ancient Chinese were making magnetic compasses thousands of years before interior designers came on board.
Nowadays, magnets are being used in the household, credit cards, electronic and industrial work. Magnets also have medical use in MRI machines in which they create strong magnetic field to take images of different body parts. And the magnet frame, which uses magnetic levitation to move itself without touching the floor, thereby reducing friction and allowing very high speeds.
First of all, what is a magnet? A magnet is an object that carries a static magnetic field around it that attracts bits and particles of predominantly iron and steel, but also nickel and cobalt. A magnet can be found in various shapes and sizes. Some of the most typical are a horseshoe magnet, a bar magnet, and a circular magnet.
Every magnet has a north and south pole. Poles that are alike repel each other. Poles that are different attract each other.
Magnets attract iron due to the influence of their magnetic field upon the iron. Before a piece of iron enters its magnetic field, the polarization of its atoms is completely random. When exposed to the magnetic field, the atoms begin to align their electron with its flow. That is why a piece of iron becomes magnetized as well.
This all leads us to more important questions like, what is a magnetic field, and how is it created? If you put a needle onto a table and place a magnet nearby and move it close to the needle, you'll notice it will be in an excitement state. That's what we mean by magnets having an invisible magnetic field that extends all around them. It can cause a pushing or pulling force on other objects it isn't actually touching, as long as they're inside its magnetic field. A magnetic field is produced whenever an electrical charge is in motion. The spin and orbiting of an electron around the nucleus of an atom produces a magnetic field, as does electrical current flowing through a wire, which explains why the compass needle moves when placed next to an electrical current.
The Earth is a huge magnet. The Earth's liquid core contains iron, which, as it moves, creates an electric current that generates a magnetic field all around the planet. It can interact with other magnets such as compasses this way. If you break a magnet, each piece will still have two poles. In fact, you could keep breaking the magnet all the way down to the scales of atom, and even the last remaining atom will still have two poles. In the end, we have managed to know so little about the magical magnetic world, but what we do know is how cool magnets are.